Hello, students. I welcome you for today's session on DAA. So, today we are going to see about the fundamentals of algorithmic problem solving. So, these are the steps that are involved in the design and analysis of an algorithm. Let us see all these steps in detail. First step is understanding the problem. Before you can design an algorithm to solve a problem, it is critical to understand the problem thoroughly. The goal is to fully comprehend the problem's requirements and constraints. There are three steps involved in understanding the problem. First one is read the problem statement carefully and understand what is being asked and identify the given inputs and expected outputs. Second step, identify constraints. Understand the constraints such as input size limits, time restrictions, or memory limitations. Third step, clarify edge cases. Think of possible edge cases or exceptions that might cause the algorithm to fail. For example, empty inputs, negative values, boundary conditions, all these can cause the algorithm to fail. Second step is ascertaining the capabilities of the computational device. When designing and implementing an algorithm, one of the critical factors to consider is the capabilities of the computational device that will execute the algorithm. The term computational device refers to the hardware, example a computer server or embedded system, and software environment, maybe an operating system or programming language on which the algorithm will run. Understanding the device capabilities allows you to optimize the algorithm to match the available resources and constraints. Now, there are two different types of algorithms which a particular device will be capable of executing. First one is sequential algorithms where all the instructions will be executed in an order, and second one is parallel algorithm where all the instructions will be executed concurrently. So all the devices based on their capabilities they will be capable of executing either sequential algorithms or parallel algorithms. Next step is choosing between exact and approximate problem solving. When solving a problem, sometimes an exact solution is necessary, but in many real world cases, approximate solutions are acceptable or even preferable due to constraints like time or memory. Now, what is the difference between this exact algorithms and approximation algorithms? Exact algorithms provide a precise solution to the problem, and it will be useful when an optimal solution is critical. Examples will be sorting a list and finding the shortest path in a graph using Dijkstra's algorithm. Approximation algorithms provide solutions that are close enough to the optimal solution but are faster or use fewer resources. Examples will be traveling salesman problem can be solved using approximation algorithms if finding an exact solution would be too slow. Next step is algorithm design techniques. There are several design techniques used in algorithm development. The choice of technique depends on the problem type and the desired solution characteristics. Next step is designing an algorithm and data structures. Once the algorithm design technique is chosen, the next step is to design the algorithm and select appropriate data structures to store and manipulate the data. So, coming to proving algorithms correctness, it's crucial to prove the correctness of an algorithm to ensure that it always produces the expected output for valid inputs. There are three different approaches to prove the correctness of an algorithm. First one is formal proof, using mathematical induction or other formal methods to prove the algorithm's correctness. Second one is base case. Prove that the algorithm works for a small or simple case. Third one is inductive step. prove that if the algorithm works for a particular case, it will also work for a more complex case. Next step we have analyzing an algorithm. Algorithm analysis is the process of evaluating the efficiency of an algorithm either in terms of time or space complexity. So time complexity is nothing but it indicates how fast the algorithm runs, and space complexity is nothing but it indicates how much extra memory is being utilized by that particular algorithm. And last step is coding an algorithm. After designing and analyzing the algorithm, the next step is to code the algorithm in a programming language. The code should be clear, modular, and maintainable. Proper data structures must be chosen to implement the algorithm efficiently. Once the code is written, it must be tested with sample inputs, edge cases, and large inputs to ensure correctness and efficiency. The implementation should be optimized to minimize both the time and space complexity if necessary. Now, what is code optimization? Actually, it might involve reducing redundant calculations or choosing better data structures. So, that's all about the fundamentals of algorithmic problem solving. Next, coming to important problem types, we will deal with the types of problems that are encountered and how an algorithm will be designed for all these problems. So first problem is sorting. Sorting is nothing but it is arranging the elements either in increasing order or decreasing order. Example for this will be a list of numbers will be provided, and those list of numbers have to be arranged either in increasing order or in decreasing order. There are two types of sorting: internal sorting and external sorting. Internal sorting is nothing but when all the data is placed in the main memory or internal memory, then that sorting is called internal sorting. Example will be bubble sort, selection sort, and quick sort. External sorting, when all the data that needs to be sorted cannot be placed in memory at a time, then that sorting is called external sorting. An example for this will be merge sort. Then comes searching. Searching is an activity where you have to find out the desired element from the list. And the element that we are searching for is referred to as search key. So there are two types of search techniques available: linear search and binary search. So in case of linear search, we will be having a list of elements, and in this list we will be just searching for an element. We will be searching the search element starting from the first element in an order till the end of the list or the end of the array. If the element is found, the element will be returned and the output will be printed as the search is successful. If the element is not present, then the output will be printed as the search is not successful. Third problem is string processing. String is a sequence of characters from an alphabet. There are two types of strings: text string and bit string. Text strings comprise letters, numbers, and special characters. Bit strings comprise zeros and ones. We have string matching algorithm to find out whether a particular pattern exists in a string or not. See, for example, we have a pattern D, E, F, and we have a string A, B, C, D, E, F, G, H. We have to check whether this pattern D, E, F exists in that string or not. For that purpose, we will be using the string matching algorithm, and each and every character that is present in the pattern will be matched with each and every character that is present in the string. If a match occurs between the first character of the pattern and the first character of the string, then both the pointers will be incremented, and again the second character of the pattern and the string will be checked. If again match is found, then the pointer will be incremented and so on until the entire pattern matches with the string. Next will be graph problems. Graph is a collection of vertices and edges. Graphs can be used for modeling applications including transportation, communication, social and economic networks, project scheduling, and games. So some of the graph problems or graph algorithms involve graph traversal algorithm, shortest path algorithm, and topological sorting. Examples for this will be traveling salesman problem and graph coloring problem. Traveling salesman problem is the problem of finding the shortest path through n cities that visits every city exactly once. Graph coloring problem seeks to assign the smallest number of colors to the vertices of a graph so that no two adjacent vertices are of the same color. Then combinatorial problems. So combinatorial problems, it is related to problems like permutations and combinations. Combinatorial problems are very difficult problems to solve because we have three reasons for this difficulty. First one is that as the problem size grows, the combinatorial objects also grows rapidly and reaches to a huge value. Second reason is that no algorithm is available to solve these problems in a finite amount of time. And also, third reason is most of the problems of combinatorial related objects are unsolvable problems. Then coming to geometric problems, this deals with solving the problems related to geometric objects such as points, lines, and polygons. So these algorithms are used in various applications such as computer graphics and robotics. We have two different types of geometric problems. Closest pair problem, where we have to find the closest pair among the n number of points that are present in the plane, and convex hull problem where we have to find out the smallest convex polygon that would include all the points of a given set. Last, we have the numerical problems. So numerical problems are based on mathematical equations, systems of equations, computing definite integrals, evaluating functions. These problems require manipulating real numbers which can be represented approximately. So thank you all.